Hi, I'll be showing something you can do in Touchdesigner with the new Ray Pop, which I think has a lot of possibilities, and I've been having a lot of fun with. So I'm just starting in my node network with a point at position 0, 0, 0 along the X, Y, and Z. It has no associated vector with it right now or direction that it's facing. And so I'm actually going to construct one with the attribute pop, where I can create an attribute out of channels. And so I'm on the x-axis, having it face a sine wave, and on the z-axis, I'm having it go along a cosine wave. With no change to the y-axis or height. This is going to be spinning around my y-axis, kind of in like a flat disk. So that's my new normal direction or vector. And using ray, I can essentially detect when that ray collides with another piece of geometry. And so here I'm giving it this sphere, this geodesic sphere. And now my normal is constrained to the surface of that sphere. So if I change some aspect of my initial sphere going into my ray, it will actually affect where that endpoint is. And I can show that with a trail. So this is the history of where my point has been after it's collided with the second piece of geometry. And I can have some fun with it. So I can change the frequency of that initial sphere. I can make it grids. So we actually get to see what this looks like along the triangle path. And I can actually reintroduce variation to my height. So I can start drawing along the faces of my new piece of geometry. So changing my height, I can actually just draw a sine wave along it. This might look a little better if my sphere is a little more populated. So yeah, I can draw along this sphere. I can introduce noise to this new vector that I've added. Or I can just draw along different objects. And I can also, using the point pop, simply add new points. So here's a second point that's going to have a higher position and just create an offset of that initial line that we saw. Same here. And these new points don't have to just be vertically in line with each other, but they can be changed along the X or Z axis as well to provide new points along my geometry that I can use. Yeah, there's a lot of fun you can have with this. Actually able to work with normals in different ways than constructing them ourselves like I did before with chops. So if we want to work with something that innately has some normal direction to it and then use array on top of that, we can just produce some information. I have here a point generator, which is generating 100 points filled within a sphere. And I'm going to change that to be a circle that exists on the ZX plane, so completely flat on my 3D space. And I'm going to turn off random so that I have them evenly distributed or circularly packed. And if I have viewer active on this little crosshairs and I right click, I can use the display attribute vectors to show with little arrows the direction of my normal. Right now, all of these are facing straight up, which is X, 0 on the X, 1 on the Y, and 0 on Z. And using this normal, I'm now able to calculate, just as I did before, its intersection with another piece of geometry, like a box. So if I create a new box, actually, I want this to go into the ray. And then I have a box. I can display exactly that these points are being translated up because their normal value falls within the box and is being translated to this top face. And what I can do then is I want to make this box a little bit bigger so that it fully encompasses my circle. And now in my point generator, I can use the transform tab or create a new pop transform myself so that I'm keeping this one the exact same. And I can now rotate along some axes. Great. So now I'm just constantly increasing the rotation on one value, which will make it loop around. And now I can see that my circle is changing which face it's hugging. Great. And now one cool thing that Ray allows me to do is if the input piece of geometry has normals itself, such as like a direction that each of these faces is pointed, whether this one be directly along Z, directly along X, or directly along Y. That will give us information for how a secondary bounce should go. So once my ray hits a certain face, it can have a piece of information that tells it, all right, now you're going to go the other way and you're going to end up somewhere else once you collide with another piece of geometry. So I can essentially make the rays bounce around the inside of this box as much as I want. And to do that, you have to add a normal attribute to a piece of geometry. So I'm going to use the normal pop to do that. And nothing changes because I need to add a second bounce to my ray. Great. And now we can see that some of these end up at the same location that they started because they're being directly reflected. But some of them end up on the other side of the box because after their initial intersection, they bounced off to another destination. This is already a pretty cool result. I sometimes like to multiply by different rates. Probably. Great. So now I have my X and my Y of this circle rotating at different rates, and we're ending up with some pretty cool reflections. And the same as before, I can actually change how this input piece of geometry exists. So instead of having really sharp corners, using the corner type, I can make this into a sphere again, and somewhere in between. And we can see that those reflections end up on different parts of our sphere or circle or box. And I can add as many bounces as I want, but it gets kind of busy. Yeah. And we're actually able to also add noise to our initial normal value. So we can actually do a lot with that initial normal value. I will randomize before I transform. So I'm going to add a noise. And this noise isn't going to affect the point position as it is currently. So right now they're all kind of being jumbled up based off of some underlying noise. I can change that by going to output and output attribute scope. This means that my noise will only affect the direction that these points face. So if I click N here, my randomization will be applied to the direction of these points. And I can visualize that by right-clicking with Viewer Active On, Display Attribute Vectors, N, and now I can see that instead of them all facing up, they're now all facing outwards. And I can increase that randomness with my amplitude and my period combined. And so now, if I visualize this with a trail, I can see that I'm drawing all over the surface of this box, but it is being maintained. Yeah, and I can actually do fun things with this noise as well. I can animate the noise itself. And we can see it gradually changing over time. Yeah, so these are just some fun options to be drawing on pieces of geometry. And I'm sure this isn't even the half that you can do with the ray pop. So have fun.